Good afternoon, Geometry Honor students. This is Mr. Chen, and welcome back to my YouTube channel. So this one is sections 5.7, so it's regarding Cpctc and circles. So objectives, apply the principle of Cpctc, and then apply some basic properties of circles. So Cpctc, what that means is consider the corresponding parts of congruent triangles a congruent. So let's say we do have two congruent triangles, so this one basically can be proved by side, side, side. So therefore, by using that Cpctc, so angle A, it's congruent to angle D. Okay, and then angle B, it's congruent to angle E. And then angle C, it's congruent to angle F. Okay, so as you can see that the corresponding part of the congruent triangles must be congruent. And also the segments, well, this one is already being proved by using side, side, side. So after that, you prove the congruent triangle. So you can say those corresponding angles. So those corresponding angles must be congruent as well. So now let's look at that some of the example. So given that segment BC bisects angle ABD and angle ACD, so you want to prove that segment AB is congruent to segment DB. So we do know that BC bisects angle ABD. So if this one's being the bisector, so that means angle ABC must be congruent to angle DBC. And also for that angle ACD here, so also bisects. So that means this one, those two angles ACB and DCB must be congruent. And one thing that we notice, so this one BC, well, that's what those two triangles share in common. So now let's start it off with the two-column proof, statements and reasons. Okay, so two-column proofs. So statement, reason, so the first statement, so you want to state that segment BC bisects angle ABD and angle ACD given. So therefore that second statement, so we do have angle ABC. So this one is congruent to angle DBC. Another thing that we notice is that angle ACB is congruent to angle DCB. And the reason for this one is by the angle definition of angle bisector. So definition of angle bisector. And one thing that we notice for these two triangles, so the segment BC, that's what they share in common. So segment BC is congruent to segment BC by using reflexive properties of equality. And continue with the proof. Okay, so let's see right here. Statements and reasons. So statement number 4. So we can show that the triangles ABC, well, which is congruent to triangle DBC. And the reason for that, it's by angle psi angle. In order to prove that segment AB is congruent to segment DB, so we can state that by Cpctc. Okay, so that means those two triangles are congruent. So we can state that segment, the corresponding segments, so those two segments are congruent using Cpctc. Okay, so now here's another example. So given that angle AEC is congruent to angle DEB, okay, so gotta be careful, so it's kind of overlapping a little bit. And then segment BC is congruent to segment CE. Okay, so this one's a little bit odd here. And then angle ABE is congruent to angle DCE. Okay, those two angles. So you want to show that segment AE is congruent to segment DE. Okay, so AE, which is this one, congruent to segment DE. So one thing that I gotta be careful here, I think there's a little typo. So this one's supposed to be right here. So for segment BC, this one's supposed to be segment BE. Okay, let me fix that. So segment BE is congruent to segment CE. Okay, so that means the line segment here. So EC is congruent to EB. Okay, so now two-column proof. Statement and reasons. So some point somewhere somehow we're going to be using that Cpctc. So I just want to set up the T table. So I just need that, the continuation, in case that I need that more space right here. So statement and reasons. So started with the given. So angle AEC is congruent to angle DEB. And then the rest of those given statements. So pretty much you can put them all there. And since we label it already, let me just reconnect this part. Triangle. Okay, so all the given that we have written down. So for the next statement, so you want to start it off with the triangle. So it looks like triangle. Well, one thing that we notice, so if these two angles are congruent, okay, so angle AEC is congruent to angle BED. So what we can say that angle AEC minus angle BEC, and which is the same as angle DEB minus angle CEB. And the reason for that, this one is by using the angle subtraction postulate. Okay. So one thing that we notice once we subtract, so that means angle AEB. So that one is congruent to angle DEC. Then this one would be by using the definition of congruent angle. So since we do know that this angles is congruent with this one, the segments, they're congruent, and also the angle down here on the bottom. So angle ABE is congruent to angle DCE. So therefore triangle ABE is congruent to triangle DCE. And the reason for that is by using angle psi angle. As you can see that angle psi angle, angle psi angle. Okay, so this will be statement number 4. And then therefore, triangle, well, this one, so we do know that angle ABE is congruent to angle DCE by using angle psi angle. So the next thing that you want to say is that angle, well, not angle, segment AE is congruent to segment DE by using Cpctc, just like that. Okay, so now let's see what else that we have. Find the area of the shaded region. So this one is only given with the radius of a circle, which is 7. And then we do know that this one, it's a perfect square. So in order to find out the area of the shaded region, the pink area, so basically just like finding the area of a square. So the area of a square, then that would be considered 14 times 14, or 14 square, which is 196. And then minus area of a circle, pi r squared. So minus pi times 7 squared. So 196 minus 49 pi. Now the thing is that this one, it doesn't say that you have to round it. So that means we just leave it as the way it is. You probably want to put in like square unit for the area of the shaded region, or just leave that with the value. So the exact value, that means there's no rounding, there's no approximation. Okay, so here's another one for the proof. So statement and reasons, the two columns. Okay, so this one. Okay, so started off with the statements and then the reasons. So always start with the given. So no matter what you need to prove, always start with the given. We don't make things up yet, okay? So start with the given. So started with segment DE is congruent to segment BF. AE is congruent to segment CF. And also at the same time, you want to label this one. So DE, which is this one. So it's congruent to segment BF. And then AE is congruent to segment CF. Another thing that we know is that angle DEA is congruent to angle BFC. So DEA and then BFC. Okay. So now finally you want to show that angle 1 is congruent to angle 2. So in order to show that angle 1 is congruent to angle 2, so that means we need to prove that triangle EAB is congruent to triangles CFD. Okay, and then using Cpctc to prove that angle 1 is congruent to angle 2. Another option is that we can show that the triangle DAB is congruent to triangle BCD. Okay, so it depends on which way that you like. So start it out with the given, as always. Okay, so now, once you started with the given, so here's another thing that you want to put in for this. Okay, so one thing that we notice, so it looks like this small triangle here, they're kind of congruent by using psi, angle psi. Okay, so definitely we can be using that, okay, but what else can we apply right here? So in order to show that the large triangle here is congruent with the other triangles, so what we need to do, let's start with the small right triangle first. So this one, well, not the right triangle, the small triangle, so triangle DEA is congruent to triangle BCF. And the reason for that is because of psi, angle psi. And then from here, we can just say that angle D it's congruent to angle, well, angle, let's put it this way. Let's say that angle AB, angle ADB is congruent to angle CBD. And the reason for that, CPCTC. And also by using the same reason, and we can figure out that segment DA. Okay, so segment DA is congruent to segment BC. And also using the same reason, CPCTC. Okay, so this one. And now what we can show next, so we can show that segment DB is congruent to segment DB. Because we want to prove those two large triangle congruent, so we can use that CPCTC again to state that angle 1 is congruent to angle 2. So this one, the reason for that, it's one reflexive, one element, so it's what, by using the reflexive property of equality. And then after that, so we can state that triangles DAB is congruent to triangle BCD. And the reason for this, it's by using well, this one here, looks like we cannot use that. It's side-side angle, there's no such postulate. So in order to prove that, so there's another thing we need to show. Well, we actually did it. Okay, let's see. So we got a side, angle, side. So side, angle, side. So we actually did that. So side, angle, side. So for the final statement and the reason, so step 7. Since we proved that this two large triangles congruent, so that means angle 1 is congruent to angle 2. And with the reasons of Cpctc. Okay? So this proof is a little bit long, okay, but the thing is that it's all logical. So it's all about using the reasoning with that given, the postulate for proving the triangle, and also some of the special property like the reflexive, dB, it's congruent to dB, things like that. Okay, so now let's see what else that we have. I think that's it. Okay, so this one, it's the end of the sections for this one. So again, any kind of questions that you have regarding the proof by using Cpctc, so make sure that you guys rewatch the video, either fast forward or just rewind it back to the area that you need more focus. Alright, so I'll see you guys next time. Have a great one. Take care.